Hello and welcome to this lecture titled Introduction to Modeling and Simulation for Buildings of the Deep Renovation for Energy Efficiency in Residential Buildings, MOOC. Within this lecture, I will provide you an introduction to modeling and simulation, and we will start answering to fundamental questions to frame the topic, such as which are the definition of modeling and simulation, what is a good model, and which is the classification of simulations. Then we will see the step-by-step procedure to understand how to develop a simulation. Following, we will focus on the role of modeling for buildings, highlighting benefits and pitfalls. Finally, to conclude, I will provide you some key takeaways before starting modeling. So, let's start defining what are modeling and simulation. They are a discipline, an experimental and applied methodology which seeks to understand and evaluate the behavior of a real system and the interaction of its parts by designing its representation, the model, and running the simulation with the developed model to conduct theories or hypotheses, to predict future behaviors that are the effects produced by the changes in the system. Now, if modeling is the process of producing a model, central question to reply is what is a model? A model is a mathematical representation of an object, a system, or an idea in some form other than itself. One purpose of a model is to enable the analyst to predict the effect of changes to the system and possibly control its behavior. On the one hand, a model should be a close approximation to the real system and incorporate most of its salient features. On the other hand, it should not be so complex that it's impossible to understand and experiment with it. That's why a model is similar to, but simpler than the system it represents. Now that's clear what is a model, let's try to reply to this difficult question. What is a good model? Of course, it depends on the question, the goal of the model, but it's also clear that for one process is not only one model. You may have several different models. And I like this quote from Einstein saying that for good model, everything should be made as simple as possible, but not simpler. So you should just kept the right level of what you want to describe, avoiding to do too much, but of course, don't oversimplify things, because you may lose then the level of detail that you need to reach the goal. So, in conclusion, a good model is a judicious trade-off between realism and simplicity. In the previous slides, we have already introduced the general definition of what is a simulation, but let's see in practice what really does it mean. Computational science of every domain equals applying modeling and simulation methods. Science is modeling. In fact, the term modeling refers to the development of a mathematical representation of a physical situation, and computational science is the execution of scientific models on a computer, which is a simulation. When you are facing with a system, two types of experiment you can perform, on the actual system or on a model of it. Then again, you may have two kinds of models. The physical, which represents, for example, scales models, prototype plans, etc., and the mathematical model, which represent analytical queuing models, linear programs, etc. So at the end, when you face with a mathematical model, which cannot study with an analytical solution, you perform a simulation. In this slide, I've summarized the typologies of simulation models to understand their classification and guide you in choosing every time the right one you need in function of their characteristic and variables. There are three main categories in which they are classified: static versus dynamic, deterministic versus stochastic, continuous versus discrete. In the first case, the question to reply is: does the time have a role in the model? Because a static simulation model represents the system in a particular point in time, while the dynamic represents the system over time. Then it follows a second question: is everything for sure, or is there uncertainty? Deterministic simulation model has no random. Variables inputs and outputs are fixed, while in the stochastic one, model has one or more random parameters. And finally, can the state change continuously or only at the discrete points in time? Continuous simulation is used to model systems which vary continually at any time, while discrete simulation used to model systems which are assumed to change only at the discrete set of points in time, corresponding, for example, to state changes. In this case, the system modeled are dynamic and almost invariably stochastic. Finally, you can even have systems which are both stochastic and static. In this case, you will perform Monte Carlo simulations. So, in conclusion, the choice of simulation model is a function of the characteristic of the system and the objective of the study.